All right, you just got your chapter for ISN, and you got your packet for today on classifying triangles. We're going to start off with the notes in our ISN, and then we'll be able to do the packet. Classifying triangles by their sides. Okay, you can classify a triangle by the number of congruent sides. Each number of hash numbers, equal numbers of hash marks. Okay, what are hash marks? You know, you've seen them before. Be something like this. So if you have a slash on all those sides, that would indicate those three sides are equal. Okay, so if all three sides of a triangle are congruent, then the triangle is equilateral. It will be an equilateral triangle. So this other one is also equilateral. In its sides, I'm going to do double slashes on. Equal slashes means equal length. When a triangle has at least two sides congruent, then the triangle is an isosceles triangle. I-S-O-S-C-E-L-E-S. And I say it kind of like that in order to help me remember how to spell it. The sides that are congruent in the first triangle are here and here. These are all variations of an isosceles triangle. They look different though, don't they? This one has all little tiny angles, and we'll be talking about the angles next. This one has one big angle, but these two sides are the ones that are congruent. This one has a right angle there, and it's these two sides that are congruent. And this one has all little angles, and it's these sides that are congruent. And I don't usually go past 4 of those slashes. It's about the most I've ever, it is the most I've ever seen on a diagram. But I just didn't want to imply anything there was equal. Okay? All right, so those are all examples of isosceles triangles. If no two sides of a triangle are congruent, then the triangle is a scalene triangle. I heard somebody saying that word. I bet somebody's learned it in directed studies already. Yep. Or maybe you heard of it before. What that means, no two sides are equal. So in this one, this side is different from this side, which is different from this side. And I'm not going to do a million different marks on here, so I'm going to just use the same ones. This side is the shortest, this side's medium, this side's the longest. Not that it has to be that way. I just chose it because the slashes work better that way. And if I looked at this triangle over here, it's another example of a scalene triangle that has a right angle. This side is different from this side, which is a different length than that side. Okay, and on this other one, this one looks like this angle is a little bigger. Is that bigger than 90? I'm not sure. Pretty close, but this side's different from this side, which is different from this side. And I did not do it in length order, because I think the longest one's here. Doesn't matter if it's in length order. All right, now that we talked about the types of triangles names, we can use those as an application. Find x and the length of each side of triangle ABC is isosceles. Isosceles means at least two of the sides are equal. In this picture, it's telling us that AB, the side here, is equal to the side BC, this side there. You need to know which ones are equal. So then I can solve the problem by setting 4y equal to 3y plus 2. Then I would subtract 3y from both sides to solve for y. And that gives me y is 2. Now it says for us to find the length of each side of the triangle. So I would plug back in 2. I would get the side AB is 8. I would get the side BC is also 8 because 3 times 2 plus 2 is 6 plus 2, and that's 8. And then the other side that's missing, side AC, 3 times 2 would not be 8, it would be 6. Okay. So the question actually had 4 answers. Okay, I believe you're changing page. Is that correct? All right, so we're going to go classify now by angles. Classifying triangles by angles is another way to classify a triangle by the measurement of its angles. If all three of the angles of a triangle are acute angles, meaning less than 90, then the triangle would be an acute triangle. I just used the triangle symbol for the word triangle. These are examples of acute triangles. All of the angles are acute. They're all less than 90 degree angles. Now, for the next one, if one of the angles, it only has to be one, and it only can be one, of a triangle is an obtuse angle, then the triangle is an obtuse triangle. I'm going to identify the obtuse angle in each of these triangles. The angle that's big and wide here is this one on the first triangle. It's this one on the second triangle, and this one on the third. Those are the obtuse angles. Note that the other two angles are really small. Their other ones are acute angles, but it just takes that one angle to be obtuse. Now there would be another option as well. And that would be that if all three angles of an acute triangle are congruent, then it would be equilateral. Oh, not equilateral. Equilateral is sides. What's equiangular? Equal angles. Now, the angles are all equal, so you might see something marked like this with a single arc on all three of them. Equiangular. Where's my equal my L coming from? Oh my gosh, I made the L way too soon. Sorry, I think it's getting tired. I'm tired. It's like a little late in the day, and this is my third time doing this, and my mind's wandering. Equiangular. Sorry, guys. Of course, it's not equiangular. It's equiangular. Gosh darn. Thanks for noticing that, Darylyn, because that made me not have something incorrect on my paper. It's not a good idea. All right, especially since I'm recording. Oh, here we go. On this next one, let's do double arc marks, reminding us that just means the same thing, except that these angles, well, they're actually the same as those, because how big do each of them have to be? Anybody know? If all three angles of a triangle are the same, each one, do you remember how much they add up to? Thank you. Yep, 180 divided by 3 is 60. That's why they're all 60 degrees. Yeah, we want to know that. So if all the... Now, think about this. What else do you think's true about this triangle? Just because it's your mind working a little bit. If all those angles are equal, what else might be true? What's it look like? I'm trying to hint. Oh, the sides are equal. That has to go, it goes hand in hand. That if all the angles are equal, all the sides have to be equal, and vice versa. So when you know something's equiangular, it's also equilateral. And that's a good concept to know. We need to know that. If one of the angles of a triangle is a right angle, then the triangle is called a right triangle. All right, so let's just see where the right angles are on these. That one's there. This one, it's here. And this one, it's there. I do not know why those are attached to each other, but oops. So now we're going to classify by angles. So I look at the triangle. It says classify each as acute, equiangular, obtuse, or right. So we have 4 choices. There's a 90-degree angle, so this one is a right triangle. And you can just write right. This one has a 120-degree angle, so it's obtuse. And this one has all angles the same, so it's equiangular with one L. And if it's equiangular, what else is it? What's another word? Oh, sorry. It is equilateral too, but I meant even of these, this list. Acute. Yeah, it could be also called acute. But the most specific word, specific, is equiangular. Not Pacific. All right, that's the end of the ISN for today. So now we're going to go over to our 4.1 packet on classifying triangles. After this lesson, you should be able to successfully, I don't know, you should, I should get rid of some of this double wording here. After this lesson, you should be able to classify triangles by both sides and angles and use this knowledge to find missing parts of the triangle. So these are the, this is just a summary of what we already went over. All three angles acute, then it's an acute triangle. If all three angles of an acute triangle are congruent, then it's equiangular. If one of the angles is obtuse, then it's an obtuse triangle. And if one of the angles is right, it's a right triangle. So this is what's on your paper. Classify each triangle as acute, equiangular, obtuse, or right. All angles are the same, so this is equiangular. The triangle has one angle that is obtuse, so it's an obtuse triangle. Pardon me? Number 3, there is a right angle, so it's called a right triangle. The triangle has one angle that is right, or 90 degrees, so it is a right triangle. You can't see that. Could you see anything when I just was scratching that screen? Probably not. All right, classifying triangles by sides. If all three sides are the same, then it's equilateral. If at least two sides, it says at least, then it's isosceles, ISOSCELES. And if no sides are congruent, then it's scalene. So this one is two sides congruent, so it's ISOSCELES. Isosceles. The double markings on this one on all three sides show that all three sides are congruent, so it's equilateral. Okay, this triangle has no sides congruent, so it's scalene. And now no hints. Number 7, all the sides have different numbers on them, so it's scalene. Number 8, all the sides are labeled with the same length, therefore it's equilateral. And all of them are different on number 9, so it's scalene. Number 10 has two sides marked congruent, so it's isosceles, ISOSCELES. And I am saying that over and over, so you try to help you remember how to spell it. So I said it with a pattern. 11, what do you think? Yeah, you see these have the same mark. Now, granted, we can't figure out X based on the information given, but because these are marked with the same number, then it would be ISOSCELES, isosceles. Okay, 12 would be All sides equal, equilateral. Believe you're turning the page now? Now we're going to do some algebra. What gets confusing to kids here is it says it's an equilateral triangle. That means that all the sides are the same length. We need to solve for x and find the length of each side. What are we going to do? Chloe? Okay, you could do 2x plus 2 equals 5x minus 4. Did anybody see another equation? What else could you do? 3x equals 2x plus 2. Yes, Kenny? He just said it the other way. Do you know why I wrote it this way? There was a reason. I just put the bigger amount of x on the left. So you were not wrong. It's totally fine what you said. Anybody have another one? 5x minus 4 equals 3x. Okay, all of those work. You got to pick a pair. They all give the same solution when done correctly. Which one looks the easiest? I think this one, don't you? All right, so I'm not kidding. You have to pick a pair. You got to go with it. You can solve any of these. If you do it correctly, you will get the same answer. This would be x is 2. Now, that's only one of the answers, but check it out. If you subtracted 2x, I'll just prove it. 2x equals 3x minus 4. You would then have to add 4, and then you would get 6 equals 3x, and you would divide by 3, and you'd still get 2. But what equation would you rather do? The one we just did. Okay, so in this one even gives it to you, but you have to do even more work because you have to, well, subtract 5x, and you'd get negative 4 equals negative 2x, and you divide by negative 2, and you'd still get positive 2. But lots more chances for mistakes with these two. So this was actually the easiest way to solve it. So pick whatever looks easiest to you because they're all equal. All right, so now we got the sides of the sides. 2 times 2 plus 2 would be 6. Okay, all the sides are 6. So SR equals RT, which equals ST, and they're all 6. You could write it like that. And now you got all your answers. No, it's not. It does. Triangle RST doesn't equal 6. It's all the sides of triangle RST are 6. Oh, the perimeter would be 18. Okay, that's true. But if it's asking you the side length, yeah, each side, it's got to be 6 at each. Okay, 14, so it says that find the length of the, this is the one that we just did in our ISN, isn't it? These two are the equal ones by what it says here. AB is equal to BC. So 4y equals 3x plus 2. Why is everything equaling 2? I do not know. So, oh, I put an x in there all of a sudden. I can't do that. Subtract 3y, thank you. We get y is 2. And then we went and found that AB would be 8. And BC would be 3 times 2 plus 2 is 6 plus 2. It's 8 also. And AC is 3 times 2, and that's 6. I know I went really quick, but we did this one. Yes, Priscilla? No. No, because you would be adding 2 sides and then saying it equals a third side, and that's not true. So you have to pick, if it's isosceles, you got to figure out the pair that are equal, to set them equal. And if it's like the last one, you have to pick just 2 of them to solve for it, right? Only any 2 because they were all equal. So no adding up the sides unless you're given perimeter. All right, Now, it says to classify, this thing has all equal angles, so it's equiangular. And this one has a 95-degree angle, so it's obtuse. One angle larger than 90. Okay, now I'm gonna be skipping to someplace else in the package soon because I think I've done enough examples of the same type. But before that, we'll get 17 and 18 out of the way. 17 is a right triangle, but look what it said. Oh, and then 18 is acute. But then I noticed that 19 and 20, nope, I think you can do those. 19, of course, is what? Yeah, obtuse. And what about 20? Acute. And then you get to 21. And there's some triangles that are kind of overlapping. Now, I would pose to you this question. How many triangles are in the picture? Okay, how many triangles are we being asked to discuss? Guess what? How many triangles are in the picture? Yes. I heard 3 at first because you obviously would go 1, 2, 3, right? But don't forget this one, right? All right. So first we're talking about ABE. What kind would it be? I'm trying to decide if it's scalene, isosceles, or equilateral. No sides are the same, so it's scalene. Ooh, calligraphy pen. Try another with the click. No. All right, highlighter. I'm going to just highlight which triangle I'm talking about. EBD. I think I better get a skinnier highlighter. That's this one. And it has 2 equal sides, so it's isosceles. ISOSCELES. And then it said EBC, which is the triangle we didn't see right away. That's this one. Whoa, that was a terrible line. Oh my goodness, I can't draw. Okay, that didn't do any better. All right, that big triangle. My cooperation is not happening. All right, so we got a right angle. So, oh, that's not what it was about. It was a right triangle, but it's also got one side that's this short, and then this one's twice as big because these slashes mean that all those pieces are equal. So it's got 2 that length. So it's scalene. All right, now, if you needed me to be clear about what I was talking about, this was the triangle. All right, and then finally, they're telling me to look at triangle DBC. Well, that's that one. And DBC's got 3 equal sides, so it's equilateral. What? All right, so they asked me about every one of them. But look at this one. How many triangles do you see? Well, someone's right. Okay, let's see if there's 4 or 5. There's the first one they're asking about, and it's, oh, but look what it says. Classify by both angles and sides. I need 2 answers. So the one I just highlighted, ABD, is both equilateral and what? If it's equilateral, then it's also equiangular. Okay, now I'm trying to help you see, and highlighting can help you when these things are attached. Triangle ABC. Now that's one that I don't think some of you counted. Or maybe you did, and that's why you said 4. But if you said 5, you were correct. There are 5 triangles in the picture. The biggest one is the one we're talking about now. What kind is it? By the angles, it is, by the angles, a right triangle. And by the side lengths, that's scalene. All right, now I'm going to go and find the next triangle, EDC, which is that one, which I think everybody saw. Angle EDC has a right angle, so it's a right triangle. And it also has one side like, oh, that's a double mark, that's a single, and this is different because it's a hypotenuse, so it's scalene. It's a right scalene, just like the big one. Okay, now I'm going to find BDC, and that's the one I don't think a bunch of people saw. There's the 5th triangle right there. One, 2, 3, 4, and then the big one, 5. Now do you see 5 triangles? Okay. All right, BDC, what kind is that thing? Well, this is 90, and then you got to add some more on, so it's got to be bigger than 90 there. It's an obtuse. Obtuse and what? Oh, yeah, because this side's equal to that side. So obtuse and isosceles. ISOSCELES. All right, now, another question for you to think. Please tell me what triangle we did not discuss. What is it called? BED. That one right there. So if I asked you what it was, it would be by its big giant angle right here, obtuse and isosceles. Okay? All right, I'm not doing these. I'm going to go to the ones where we graph because I want to show you how to do those. So I have accidentally picked one that has some writing on it, so I'm going to get rid of that stuff and start it over. Alrighty, so let's go ahead and plot the points. -3, 2 is left 3, up 2. Label it K. 2, 1 is right 2, up 1, P. And -2, -3, left 2, down 3. There's L. It doesn't matter if you don't have a straight edge. Just be as straight as you can. Some people use the calculator. Okay, I've got a triangle. I have been asked to figure out what kind of triangle it is by its sides. So that would make me need to know how long the sides are. How can we figure out how long the sides are? So I need to know the distance from K to P. You heard the word distance. So what does that mean? I can't count. I mean, I can't just go 1, 2, 3 like that. I don't know. So we do the distance formula. Now, I can make it easier. I can make it hard. It's on a grid. So instead of distance formula, I'm going to kind of use the distance formula, but I'm going to really use the Pythagorean theorem, okay? Which says a squared plus b squared equals c squared, but it's really going to be the distance formula because I took the square root. So what I'm going to say is I'm going to do this length versus this length, okay? So I'm going to do the square root of. Because it's on a grid, here's the easiest way to do the distance formula. Instead of taking and subtracting all these coordinates, which would be 2 minus -3, and that would be 5. Look at this. 1, 2, 3, 4, 5. You see it? 5 squared plus vertically 1. Okay, 5 squared plus 1 squared. Figure out that part. That's 25 plus 1, which is square root of 26. You can leave it in radical form. Now, let's figure out the distance from K to L. Square root of. All right, now I'm going to count from K to L. It doesn't matter which one you do first. We're not trying to do slope. I'm just going to see what this is and what this is. 1, 2, 3, 4, 5, and 1. 5 squared plus 1 squared. It doesn't matter if you do the x part, if you do the horizontal part first or second. That's going to give you the same answer, isn't it? So right now I know it's isosceles, but I still need to figure out the distance from L to P. So then I go like this. Count over from L to P and up. And that's 1, 2, 3, 4. And going up, 1, 2, 3, 4. So that's the square root of 4 squared plus 4 squared. And that's 16 plus 16, which is square root of 32. Uh-oh. Two sides are the same. So it's isosceles. If all three sides had been the same, it would have been equilateral. Okay? Now, you can make the distance formula easy or hard. That's the easy way to do it. Much less mistakes than if you subtract and square. All right, so let's try it again. Try to get ahead of me. I'm going to just get this plotted. Make sure you check if you plotted correctly before you continue the problem. I had some people plot wrong earlier today, and then the whole problem is messed up. Remember that the first number is left or right, the second number is up or down when plotting points, x, then y. All right, so weird triangles should look like mine, or thereabouts. The points better be in the right place. Okay, go. If you got your triangle graph properly, go for it. Now figure out L to P, L to K. It doesn't matter what order you do this, and P to K. I think it looks isosceles, but we have to verify that. All right, start counting. If you want to make solid lines, it really doesn't matter. That's what you need to know. All right, so if you did L to P, did you get the square root of 25? And that's how much? It's actually reducible. I mean, you can do the square root of 25. It's 5. Okay, find L to K. You guys need to practice. Do it, please. What's that? You don't have to. Just leave it whatever it is. I'm sorry, I still don't know what you're asking me. No, I don't mind answering. I just want to know. Yes. Oh, yeah, me too. I can hear you very clearly. All right, you got square root of 52? And some of you are being lazy butts and you didn't do it. That's why you don't know how to do it. Practice. Some of you still can't do this distance formula. Okay, go P to K. Come on. Do P to K. Should have gotten this. What's that telling us? These weren't equal, were they? Very close, but not actually isosceles. So what is it? Scalene. Square root of 53 is not the square root of 52. Very close, but no cigar. You ever heard that silly saying? That my father used to say that. Close, but no cigar. I don't know what that's supposed to mean, but it didn't make sense to me either. Okay, so guys, try 36, please.